so worksheet 4 and 6 today. We're going to start on worksheet 6, side B. That's just more log property examples. So we already know what we're going to do there. We just got a little more practice. And then on worksheet 4, that's our introduction to using the TVM application solver on our calculator, where we're going to see some more realistic real-life examples of what annuities and mortgages and things that actually happen in life, not these magical bank accounts that collect 9% interest, which don't exist. All right, so before we get to the worksheet 6B, I know on your homework and also on your upcoming test, there's a question that asks you to evaluate logarithms. So the directions will say evaluate, and it'll say something like log base 2 of negative 32. So I know there's at least one on your homework that's like this. And many of you have found some magical things on your calculator that magically solve things for you. But remember, you're required to know that you could rewrite this in the brain-friendly notation of 2 to what mystery power will give you a negative 32. So then you sit and you think about that for a while. And you're not going to have a lot of luck, because there is no such power where if you raise 2 to a power, you come out with negative 32 as an answer. So let's talk about why. Oh, that might have been a bad example, though. Is that no, that's a good example. Ignore me. All right, so let's talk about this. I know this is not brain friendly, but let's talk about the logarithm base 2. Let's look at it from a graphical approach. If you were going to graph the logarithm of base 2 of x, just the function log base 2 of x, it would look something like this. So if you were going to take that function and you were going to apply it to x equals negative 32. Well, guys, x equals negative 32 would be like way out here on the x-axis. Is this logarithm ever going to contain the point x equals negative 32 comma anything? No, it doesn't. It's not defined past x equals 0 because of the asymptote. So what you're going to say for this answer is undefined. Okay. I know sometimes people put 0 with a line through it. I'll accept that. I just rather you write the word undefined, because your logarithm function is not defined for values of x that are negative. Got it? So when you hit that on your homework, which you probably already have done since you totally did your homework this weekend to get caught up on everything, and then when you hit that on your test on Friday, just make sure that you're understanding there are cases where logarithms are undefined. All right, on worksheet 6B, a little recap of using the change of base formula. So a little history on change of base formula. Back in the day, and I'm talking like before my day, like my parents' day, so your grandparents' day, they didn't have calculators to do anything. They had other things, and a lot of times they were given gigantic charts, and this is one of the cases where they were just given a big old chart. So they would have a chart of the common logarithm and the natural logarithm, which is why your keypad has both common log and natural log as quick key buttons. And what they would have to understand is that through solving an exponential function, which we'll learn about later, log base 2 of 7 ends up being the ratio of the common log or the natural log of 7 divided by that same logarithm of 2. So then what your elders would have to do is they'd have to go to the chart and say, okay, what's the natural log of 7? And they jot down that decimal. And then what's the natural log of 2? And they jot down that decimal. And then they'd have to divide them, like 4th grade style. And then they'd get an approximated answer of 2.81. So many of you have already discovered the art of the change of base button on your math apps. That's cool. And when an appropriate moment to use it, please do use it. But practicing PreCalc when it specifically asks you to do it without a calculator isn't one of those moments, okay? So, like in science class, when your teacher says, like, you know, just get the answer, and they don't really care how they want you to get the answer, yes, please use that application tool. But you have to know for an upcoming lesson that change of base is a derivation of how we're going to solve logarithmic and exponential functions coming up. Okay, it's not like, I think we've learned this in math by now. There's no formula in math that like magically derived itself. It's derived through repeated mathematical calculations, and then someone goes, hey, I seem to be doing the same 3 steps over and over and over again. Let's make this a quick formula. And then they come up with something like this. Change of base. Okay? Just be familiar with it. I don't really care which one question you do, but if you could choose to do one of these questions on your calculator using the change of base ratio. So it is either the common log of the number divided by the common log of the base, or you could do the natural log of the number divided by the natural log of the base. The important thing for you guys, though, is to remember to close your log function before you type the next log function. Because a lot of kids are a little sloppy with their parentheses and then they get the wrong answer. So choose one of those questions to evaluate, and I'll tell you what I got as answers approximately, and you make sure you get one of those answers. This one is approximately 1.86. This one is, I can't read my writing, but I think it says 1.61. And this one's approximately negative 8.71. So choose to do one of those on your calculator. Confirm that you can indeed get those numbers, and then if you can, let's move on. All right, so the next part of your lesson is going to ask you to recall the logarithm properties for expanding and condensing. And because it is pre-calc, these are going to be kind of weird, nasty terms, and we have to step it up from Algebra 2. Otherwise, we'd just be living our lives over again in Algebra 2. So here you have a natural log, and inside of that natural log, I see a couple of things happening. I see x to the second power being divided by 3x plus 2 being square rooted. Now, we don't really work with square roots in logarithms. I'd much rather see them as a power. So first thing we have to remember is, how do you write the square root as a power? So it's the quantity 3x plus 2, but raised to what power? 1/2, yeah, 1/2. 1/2 power, very good. So, that's great, except now we have to expand it. I'm hoping in the very near future you guys are going to feel comfortable, and I encourage you to do so, to do most of this in one step. It's okay if you need to take intermediate steps, particularly on your notes, and if you're on a test. If you're not comfortable with them, I don't suggest you do it in one step, because you'll have no chance of partial credit if you do it in one step and you get it wrong. But let's take a look at our overarching properties here. I have a quotient. So how do you split up a division problem? Subtraction. So this becomes the natural log of x squared minus the natural log of 3x plus 2, that quantity being raised to the 1/2 power instead of the square root. So then the only other thing we can do, yes ma'am? If you put the square in. Oh, this guy out here? No. As long as you know it's just x being squared, not the logarithm. Yep. I like either one of those. Either way, what's going to happen to those exponents? They're going to come down in front of their logarithms. Yep. So I know some of you, even on a Tuesday morning after a Veterans Day weekend, are like, I could have got that answer without showing that intermediate step. Awesome. I'm a little slower today. All right, so we have 2 times the natural log of x. I like when there's parentheses around the stuff in the logarithms, but that's up to you. Minus 1/2 times the natural log of 3x plus 2. Now, this is where a lot of kids get paranoid because they're in pre-calc, and they're like, 3x plus 2, I'm probably supposed to do something with that. Like, can I separate that into different logarithms? So when you have a polynomial like that, unless you can factor it, there's nothing more you can do, because you cannot take the logarithm of an addition problem and somehow break that apart without factorization, because your properties only work with multiplication, division, and powers. So 3x plus 2 cannot be written as a multiplication question, it can't be written as a division question, and it can't be written as a power question, so you're done. That's an expanded version of that question. So let's look at number 10. Again, this is very pre-calc-y. Yes, ma'am? So if like it was 3x plus 6, for instance, so you could factor a 3 out, and in the logarithm you'd have log 3 parentheses x plus whatever I said 2, and then you could break that multiplication problem into log plus log. Yep. I hope I don't give you one of those. I probably wouldn't give you one on a test. I mean, maybe on a homework assignment. Who knows what the SAT will do to you, though. All right, guys, let's look at number 10. We have log base 2, and I see the first term, which is being raised to the 3rd power, and then you have another term of x plus 1, and we're multiplying those terms together. So remind me, how do you split logarithms up when it's a multiplication problem inside? It expands into log plus log. I heard addition. Very good. So we have logarithm base 2 of 2x quantity to the third power. Okay, I'm a little concerned about this one. This comes back to Miss Mary's question. I'm glad you asked that one. So we have log base 2 of x plus 1 over here. Now in the previous example, we talked about addition problems. If they're not factorable, no powers, no quotient rewrite, that you're stuck. So like this logarithm is good to go. But let's talk about this logarithm. Who's being raised to the third power? The 2 and the x. So you have a choice to make. You can either distribute the third power right now and call this 2 to the third x to the third, or you could bring the power down, which is what most kids do. So let's talk about that. So they write down 3, and then they have log base 2, and then they see this as a multiplication problem, so they further split this up into log base 2 of 2. And then this is what they write down, and I want you to tell me why this is wrong. What's wrong? That third power that you brought down was thusly supposed to be distributed into everything that followed inside of that logarithm. So you either would have to put these logs in parentheses to indicate distribution, or what else could I do? Like just distribute it. Yeah, which is what most people would do. So as long as you distribute the third power in front, that's great. And then actually this question has even more fun going on. Let's talk about this, guys. You've got 3 times the log base 2 of 2 plus 3 times the log base 2 of x. This one does not get a 3. That third power was not distributed all the way to here. So plus log base 2 of x plus 1. I claim we're not done. Talk to me about log base 2 of 2. Cancel out, the first power drops down. This is really 3 times 1, better known as 3. So this is really 3 plus 3 log base 2 of x. Whoopsies. Plus log base 2 of x plus 1. So if your job was to expand, that is technically the expanded answer. You could rearrange the terms order, but technically that's the right answer. That was fun. So pre-calcy of us. That was a lot of stuff going on, guys. All right, let's look at number 11. Actually, I lied. Let's move ahead to the other stuff. Condensing. All right, so this is where you could make a hard argument for Abruzzo. I can do these without showing work, and I, in most cases, will accept that. What I will not accept is a kid who doesn't show any work on their homework and then can't do anything for me on the test. That's going to make me a little paranoid and weirded out. So make sure that if you are not showing work and you are truly doing these in your head, that you are A, checking the answer key, and B, making sure you're not just copying the answer key, because you're going to be asked to do these, obviously without an answer key when you have your test. All right, so let's talk about when you're condensing or collapsing down to one logarithm. I have no problem with you guys saying, Abruzzo, I can do it in one step. Watch me go. All right, powers, go back up into the power. So these coefficients really belong up here. Well, there's no other coefficient there, so leave that one alone. But how do you collapse log minus a log? What does this turn into? A quotient, a division problem. So the first logarithm indicates your numerator, which is 3x minus 5y to the 1/2 power. And then your denominator is the second logarithm's inside stuff, so the 4x plus y. However, I don't think this is probably the answer that would be on like a computerized answer key. Anyone have a thought of what they might go back and change even more so than this? The 1/2 power is going to be changed to a square root. So this becomes the natural log of, gross, the square root of 3x minus 5y over 4x plus y. That is a condensed answer, and that's as simple as it gets. Simplified as it gets. There's nothing simple about that question. So that's the big difference, guys, between Algebra 2 and PreCalc. Like, your bases, your terms are going to be funky. You have weird powers. You got to know really easily convert between radicals and powers. Let's take a look at 14. There's a lot going on in number 14. I have a log plus a log minus a log plus another log. Now, all of these log terms, they're movable. Like, you could rearrange the order of the terms however you see fit. So one thing I notice is that this right here, this is the only part of the question that is subtracted, which means that is the only stuff that's going to be in my denominator. Everything else is log plus log plus log. So how do you condense or join log plus log plus log? You'd multiply all those together. So if we were to collapse this down into one logarithm, it's a common log, and all these blue pieces are multiplied together up in my numerator. So you've got a y, you've got a 3, and then this isn't really a z. What is this? It's really a z squared. So normal math students would call that, in normal order, 3 times y times z squared. Now what's in your denominator? That would be from this logarithm, and it's x to the 1/3 power. But we just learned that probably PreCalc doesn't like us to write x to the 1/3 power. How are they going to have you rewrite that? The cube root of x. Very good. Very good. So guys, I'm not going to disagree with you. If you're like, hey, I could do these in my head in one step. I can collapse these back down together. I think that's great. Are you asking me about rationalizing next? Well, today we can. I know. You know, it's really a dumb rule, and your calc teacher tells me, like, we really don't. It's antiquated. I know. She's pointing out, according to old fat man rule, we're supposed to rationalize the denominator. I'm just assuming it's an old grumpy fat man who made that up. We've had this discussion, right? Yeah, I'm sure. All right, let's take a look at number 15. Uh-oh. This time, how many terms or things are going to be in your denominator? Yes, so this subtraction indicates that all this stuff is going to end up in the denominator if you kind of think about distributing the negative through. Now, let's talk about joining these up in the numerator. This becomes log base 3 of... Alright, so up in the numerator you have no exponents here, so it's just xy. But in your denominator, let's see, what do you have in your denominator? You have another x, and then you have z to the 3rd. And Abruzzo claims you're not done. Look within the logarithm. Now, this one I would expect you guys to notice. You see how the x's are going to knock each other out? What that tells me is that earlier in my math, I must have had some logarithms that canceled out, and I didn't notice it until now. So look back here, guys. Let's get rid of my... Oh, that didn't help. Let's get rid of my scribbles. Right away, if you think about common terms, right here you have log base 3, and then later on, right after it, you have minus log base 3 of x. What's going to happen to those terms? They're going to knock each other out algebraically. So if you didn't notice it from the get-go, when you go down to this step, you're going to notice that they cancel out inside the logarithm. So that's kind of nice. So final answer, log base 3 of y over z to the 3rd power. All right. I have a headache. I don't want to talk about the Richter scale today. Can you guys move on to worksheet 4 and make sure you have a working graphing calculator? So worksheet 4, the front side, that's your notes. And your textbook calls this financial literacy. And I really wish we could kind of join forces with your consumer ed and econ classes and kind of make this a big thing. Because I wish, as a not so young adult anymore, that I actually taught this class before I bought a house. I would have been much wiser. This unit is your first experience in what is really truly a real life application for money. Because every application we've had up until now has been pretty stupid. It's been like, you know, you put $100 in a savings account that collects 9% interest. Like, that doesn't exist, is my first issue. And then you leave it there for 25 years. No, probably not. And you never make any other contributions to it. That's pretty weird. Just nothing we do in Algebra 2 really logically makes any sense. So finally we're going to show you, first of all, why we didn't tell you this in Algebra 2. Because in order to do these real life questions, you'd have to use this formula. Oh, okay, never mind. Yeah, that's not really an Algebra 2 moment, is it? So here's the good news. You aren't going to use this formula either. Do you think there's some banker over at like Illinois Bank and Trust like whipping out their TI-84 and saying, hold on, let me calculate your mortgage payment on my trusty TI-84? No. They have a computer program where they can enter information and then blammo, the answer pops out at them. No one physically does the math, but someone does program it, right? So you guys are going to do a littler version of using a financial application on your calculator. So our questions today and for the rest of this are going to be sometimes just as lame as Algebra 2 questions, but most of the time really quite applicable. For instance, someone who's putting money into a retirement account, or someone who is making continual deposits. That's very different from what you guys did in Algebra 2. In Algebra 2, you guys never made extra deposits on those bank accounts, right? Like you stuck some money in there and then you walked away for 2 decades. Because that's what people do. Or mortgage questions. We're going to have like a whole consumer ed lesson coming up, guys. And I'm only expressing all of this information to you today because I want you to live from my mistakes. Okay, I'm going to go off camera for a minute. All right, so our problems today are going to be referred to as annuities. Sometimes it is a problem where you're investing money towards a bank account that starts at nothing, like a retirement account. Sometimes it's a problem where you take out a gigantic loan and you're trying to pay it down to nothing. So as far as what the variables represent, we have to really watch what that is. Now, that's actually all I'm testing you on, guys, is do you know how to use this computer, which means do you know what the variables represent? So on the time value of money solver, which is on your calculator, you're going to have various variables that you have to know what everything sets up as. It's already on your notes here. So as we do our questions and our notes, what I want you guys to do is to handwrite on your notes like, oh, I put this in for N, I put this in for PMT, I put this in for, FT or FE. So here's what everything stands for before we get to the calculator. N is the number of payment periods throughout the entire course of the loan. So like, for instance, on a mortgage, you might pay it monthly, but you're going to pay it monthly for 30 years. So this number would be like 12 times 30 in that case. What's cool about your calculator, you don't have to even calculate that. You can just type 12 times 30 and it'll pop it over to 360 for you. Okay, present value is exactly what it seems to be. It's current value of your annuity. So if it's a mortgage, it's how much you took out from the bank. If it's an annuity, like a savings account type thing, it's probably 0 because you don't have any money in it yet. Future value is exactly what it sounds like. It's what you will have in the future. So for a mortgage, what should be your final value on your mortgage? You should pay it down to 0. If it's a savings account, often that's what you're trying to find is the future value. Payments per year and compoundings per year are going to be the same number. It's going to automatically transpose one to the other number once you type in the first one. And that just stands for like how many times you collect every year. So if it's monthly, you put a 12. If it's quarterly, you put a 4. This is kind of weird. They want your interest rate written as a normal number. So like 7.5%, instead of converting it to 0.075, you'll just type 7.5. And then payment amount is exactly what it sounds like. Are you putting money towards something every month or every quarter or whatever you're doing? If so, that's called your payment. Sometimes that's what we're calculating. So let's look at this first example. It says you're an investor and you are paying $600 quarterly into an annuity. So this number here, 600, that is called your payment. So on your notes, you're going to want to write down PMT equals 600 because you're going to want to refer back to this when you go to do some problems on your own. Now it says we're doing this quarterly and we're going to do this for 15 years. So quarterly means payments per year is 4 and compoundings per year is 4. But for N, you're going to contribute quarterly, but for 15 years. So you can just call that 4 times 15. Your calculator will convert that to a 60 for you. Okay, 7.24 is your interest rate. So you're going to type 7.24 right there. But on your notes, fill it out. The present value, so like when you open the annuity, it has nothing in it. So that's a 0. And this is what kind of confuses kids. They're like, what's my future value? Well, yeah, that's the question. What is your future value? So this is what you're going to calculate. So what I want you to write there is I just want you to write the word solve. I'll show you what I mean in a second. So get all that written down in your notes and then meet me at your calculator. Oh, by the way, the payment, it has a beginning and ending option. We're always going to have the default end selected. For you guys, it really doesn't matter. It's when are you distributing your payment, at the beginning of the month or at the end of the month. For real life, it does make a difference because it depends on when you cash out your annuity. but for us, let's pretend it doesn't matter. So let's always be the end. Okay, so on your calculator, go to what's called apps. And the very first one says finance. Now, if you're in test to press mode, this is all you see is finance. And then in the finance option, the very first one says TVM solver. That's the one we're going to be using. So now you're going to type in all the information you have. The only exception is the future value thing is we're going to solve that. So don't worry about that one right now. So I already forgot what this was. It was 4 times 15. If you wanted to convert that to 60, you can. It'll do it as soon as you hit enter, though. 7.24 for interest. Present value is nothing. We're paying $600 every month. And this is an overtype menu, so if you already have data in there, just overtype it. It'll delete it out as you type. What's the rest of it? I forgot. Oh, 4. So future value, leave it alone for a minute. For payments per year and compoundings per year, if you change the first one to a 4, it's supposed to change the next one to a 4, but it didn't, so just type a 4. I thought it automatically changed. I lied. Once you get all that typed in, go back and bring your cursor to where it says future value. Just remember, we didn't do anything with that one yet, because according to our paper, we're supposed to actually solve for future value. Now, you guys have never had to do this before, I don't think, but there is a solve feature on your calculator. It's on the enter key, and it's written in green probably because it's found through doing the alpha shift. So while your cursor's sitting in future value, hit alpha and then enter, and it will solve for you. And there's a little dot next to it. See that? That means I just did something. So you get a negative number. Can we talk about that? This person's like retirement fund or whatever is currently at negative $64,102.91. Now, why is it negative? That's kind of confusing. It's not that he owes the money. It's that the bank owes him. At some point, the bank is going to have to cut a check to him for $64,102.91. A lot of that money was contributed by him. His $600 every month was quite a bit of that money. But all the rest of it was accrued through interest. So the bank has to then cut a check because he kept paying them $600 or whatever he's investing in. And then they're going to write a check. That's why it comes out negative. So it's like that thing in physics when your teacher tells you, like, just ignore the negative. Like, same thing. Just ignore the negative. Okay, so here we go. Ignore the negative. So jot that number down. This dude's going to have $64,102.91 at the end of 15 years. Cool. All right, let's talk about a mortgage question. Then you can all be depressed and you can go on in life and not want to buy a house after this. All right. At the bottom of your notes there, it says you borrow $170,000 from the bank to purchase a home. So a very typical home price for this area, $170,000. Most mortgages are 30-year mortgages. And actually, this interest rate's very appropriate for right now. They are between 4 and 5% for mortgage rates. So what they want to know is what's going to be your monthly mortgage payment. Now, side note, this does not include real estate taxes. So tack on an extra $300 to $400 for that, please. All right, so let's talk about N. So on your notes, you should write all these down. N is going to be how many times you collect some sort of a payment throughout the course of the loan. So it's a monthly payment for 30 years. So that would be monthly payment times 30 years. Which means my payments per year and my compoundings per year are both going to be 12s. The present value of your loan is what you take from the bank, so $170,000. And the interest rate is 4.5%, so you're going to write 4.5 there. Now the future value for your loan, so at the end of your mortgage, how much should you pay down to? Better be 0, otherwise you miscalculated something, or you missed a payment or something happened. And then this last one, the payment, that's the question, right? So this is what you're going to solve. So besides payment, you're going to be able to fill in information for all the rest of the things on the TVM solver. And it'll change that N to 360 for you. You don't have to do that. You ready to get super sad, children? This is why they tell you to stay at home with your mommies and daddies as long as possible. All right, leave payment alone. We'll come back to that one. So once you get everything else typed in besides the payment, bring your cursor back to payment. And when we command it to solve, it'll overtype, so you don't have to clear it out. You can clear it out. But bring your cursor back to payment, and then alpha enter, so it will solve. And again, it comes out negative because someone's paying out the $861. Turns out this time it's you. You are paying $861.37 every month. It's exciting. It doesn't sound too bad, right? It's like rent. You gotta pay like almost $1,000 in rent. What's cool about owning a house is that you actually own it. So when you pay down that principal, if you decide to sell later, whatever the difference is between your current value and your sale price and your mortgage loan, you get to keep that money, assuming you have equity and you didn't buy in the peak and your market didn't crash and you actually get a sale. You know, all that. All right, this is the depressing part. You paid $861.37 every single month for 30 years. How much money did you actually pay for this house? Well, you're going to type $861.37 that you paid every month for 30 years. How much did this house cost you? Too much. Oh, this is sad. $310,093. And don't forget that 20 cents. That makes all the difference. Oh, boy. Now, this is not a testimony for like why you should rent for the rest of your life, guys, because that's actually probably not financially responsible either, because renting, you're just throwing your money away. But if you're not in a position to buy comfortably, then yeah, you need to rent. There's some cool things, and I hope they do talk to you about this in like econ classes, maybe not econ, but in consumer ed a little bit. There's ways to manipulate your loan so it's a little less scary and you're paying more on the principal. Like for instance, and I didn't know this until I became a home buyer and like some telemarketer called me one day and told me about this. I had no idea. I never thought about this, and I'm a math person. So let's say you pay your mortgage every month, which is typical, right? So how many mortgage payments do you make in a year? 12. So they said, well, what would you feel comfortable paying half your mortgage every 2 weeks? And I was like, well, yeah, because that's like the same, isn't it? And then they're like, well, not quite, because if you pay every 2 weeks, how many times do you make a payment throughout the year? If you pay, okay, 26, right? Because there's 52 weeks in a year and you pay every 2, so you have 26 payments. So if you made 26 payments of halvesies, you just made 13 full mortgage payments, right? Because if you do every 2 weeks, that's like the equivalent of 13 months. So you made an extra mortgage payment, but you didn't feel it, right? Because you're paying every 2 weeks, so you're like, whatever. I don't really notice it. Well, what happens to that extra $1,000 that you put in? Because you did. You put in an extra $1,000 throughout the course of a year. Where does that $1,000 get applied on your loan? To the interest or to the principal? To the principal. So remember that first year of my mortgage, every time I paid, I was only paying down like, $23 on my principal. Except for that extra $1,000 that I didn't even notice coming out of my bank account because I paid every 2 weeks instead of every month. So that's neat. So these are these little tricks that I feel like I was really sabotaged in life that no one told me about this. I should not have been a 20-whatever-year-old finally figuring out how mortgages worked. Oh, sad news. You guys are going to be in better shape. You're going to whip out your TI-84 at your loan account appointment, and you're going to be like, wait, I need to use my TVM solver to figure out the answer to this question.